Get up on the stage, Mog. Okay, you're a sleeping child. I completely understand. Yesterday, Tau Stats passed us as the largest validator in the network. Mega congrats to Mog. It's bound to happen, actually. It's bound to happen eventually. We'll be overtaken. It's guaranteed. But the reason for this call is that I'm here to convince Keith to child key OTF on all subnets so we can go above Tau Stats. Yeah. Well, we missed last week's. Some of you that have been coming to Open Dev have been seeing what we've been doing. We've been moving very fast, moving a lot of things on DevNet. We really wanted to get another RAW games out this week, but we've been kind of adding new things into that games slowly. We have like a new CLI branch that's coming in. We have a new version of the CLI that's using Ben's amazing work. That's cleaner and more beautiful and more well documented. We kind of want to make the CLI so good that when you guys use it, you don't even need to read the documentation. At the same time, we also have an asyncio Bittensor coming out for the SDK, which is really exciting. I don't know if many people have been asking that for a long time, but personally, I am always looking to use asyncio and Bittensor, and it's annoying that it's synchronous. So we finally got that done. It took a long time. It was very hard. We had to rewrite the Pi substrate interface basically from the ground up, which is, really makes sense. We should be just taking over all of the tech from bottom up. We also have been making a lot of changes to the commit reveal to make that a lot more easy to use for people. There's currently, I believe, going on testnet today, the updated commit reveal workflow. So it's way easier. It's like a simple single command for people rather than this kind of complex mechanism where you needed to commit and then reveal later, and subnet owners were just not implementing that. So we actually made it work in the background with a process, which is nice. So you can just rest easy and implement commit reveal, stay calm and implement commit reveal. So that will help all of the non-weight copying validators. I'm sure we can talk about that later on the stage here with Keith, who's one of the most consistent validators in the ecosystem. Also, we did hear a lot of feedback regarding EVM. People freaking out. Like, this isn't Bittensor, right? You're backing off the real design. Like this isn't the vision. Don't be a degen. And I was just like, hey, we're just expanding the language. Let's take as much into Bittensor as we can. I didn't know it would be so triggering for so many people, but we're always listening to people, and we're not gods. We don't know the consequences of everything. It's very difficult to know what the consequences of any cryptographic system are. Like, we're all basically testing in production all the time. And I tell this to people that are coming to work in Bittensor. I'm like, well, it's very fast paced because there's just a unique quality of running incentive mechanisms where you can't really test on the test network. The real technology only really shows its face when you have people trying to destroy what you've built. And that only comes in when you have a little bit of incentive, and then you get to really test you can do a good job of looking at the game theory of what you built, but you don't really know until it's out in the wild. So when it comes to all of the updates that we are bringing into Bittensor, we always ask ourselves, how can we smooth this in slowly? Like, how can we bring these technologies into Bittensor so it's not so disruptive, but we can, as a community, slowly learn about how they improve our network without getting all the negatives. So with EVM, our plan is to launch EVM, but in a very constrained way. So day one, it'll be like a very permissioned design where certain individuals from the community can basically apply to get a contract on the chain, and we're going to see how that plays out and learn a lot about how degenerate we all are, and then later on we'll be able to open that up through governance and eventually, hey, laissez-faire. We just need to make sure that we always set the tone with these technologies, and then we can open the door and the floodgates similar to what we did with subnets, right? It was just OTF building subnets, and then everyone was building subnets, and that's been obviously a fantastic experience. Here we are with Zion on the stage, with Keith on the stage, subnet owners and validators that have had the opportunity to showcase how to build this technology better than anybody else. So that's happening in the background. We got commit reveal. We also have, I don't know if I can really demo this. Definitely can't demo this, but we're taking advantage of things in GitHub right now that allow us to actually do multi-signature deploys through GitHub Actions, which is keyless, and we can even we're hoping to build in democracy directly into a GitHub interface, which is fantastic because it's really the best security in the world. So we in the future, we'll be able to literally run upgrades and have votes through a GitHub interface, which is super exciting. So that's been happening behind the scenes. And what else? Gosh, RAW Games is moving. We've learned a lot about how we can reduce the chain bloat. We need to prepare ourselves when we flip the switch to make this thing very foolproof and future-proof. So we're going to really try to make it so it's a liquid design that's easy to use, that doesn't use too much space in the chain. Anyways, I'm not actually on the stage here to talk about what OpenTensor's been doing, although I feel like I need to plug, because you guys should go stake to OTF. We need to get above MOG. That's the real important thing here. No offense, MOG. So anyways, Zion, Keith, thanks for coming up on the stage today. We are going to talk about MOG. Yeah, exactly. Fuck the miners, fuck the MOG. No, we all love MOG. Hope to see him quite soon next month. So Zion, we're talking 39 and 36. You're a double subnet owner. How does it feel?
Yes, indeed. It feels great. We've been getting deeper and deeper into the Bittensor matrix. We've got some stuff outside of the subnets too that some people might have heard about, like Taupill, which we did with Sandy Kasab, and a top secret project that we're not quite ready to reveal yet.
Should we just end the call there? That's it. We're not going to reveal anything.
I'm going to turn my camera on. Don't be scared. Hello, everybody.
Totally not crypto degens.
Absolutely not.
They just emit legitimacy everywhere they go. And why is there no pregnant men menu? I think last time did he give birth?
Oh, hold on.
There you go. There's the baby.
Right here. In case we got to go there, I'm ready to go there.
Well, congratulations.
I can take this in a more serious direction because we're not just internet trolls. So the way we think about advancing AI, I think there's sort of three important aspects to that. There's compute, there's data, and there's human expertise / attention, very loosely speaking. So on the human expertise and attention, that's where our viral apps come in. That's where the stupid pregnant man stuff comes in. They're just a good way to put a lot of eyes on something. On the compute side, for those familiar with edge maxing, the purpose there is to make the consumer devices that people already own, the MacBooks, the PlayStations, the gaming computers, much more capable and able to run models faster and more efficiently in ways that they previously couldn't. And now with Subnet 36, which we're sort of just talking about for the first time today, we're planting our feet on the data side as well. So we've kind of got all three aspects covered now: data, compute, and human attention. I'm going to share my screen here, if that's all right, and just give a quick background.
Yes, we can now.
So at the start of the month, Keith put out a call for a subnet and shared some information about Wolfram Rule 30. This is actually my first time learning about it, but some of my more intelligent teammates had known about it already, which was cool. And we sort of instantly jumped on this opportunity because it fits so neatly into everything we were doing and sort of our desire to get more deeply into Bittensor. And so this was October 4th, about the start of the month. Basically the same day, a very interesting paper called Intelligence at the Edge of Chaos was released. There was a tweet about it on, I guess, AI Twitter that some of you might have seen. And the elementary school explanation of what's going on here was they would take these cellular automata, which are really simple programs that sort of evolve in a rule-based way and then exhibit unusual behaviors. So they trained a GPT-2 type model on predicting the sort of next step of these cellular automata. And they found that by doing that, they were able to get it to perform quite well on certain kind of pattern recognition and reasoning problems. And so instantly, like, we started thinking, okay, well, there's an interesting opportunity here. They did this on a very small data set with a very small, like, GPT-2 sized models. What if we scaled this out and made a much bigger data set and tried this on a much bigger model? There's some additional background on Rule 30 here. So as you can see, it sort of evolves over time. It looks like a pyramid, and it's sort of the cell above instructs what you do in the cell below. Our tentative name for this new subnet is Pyramid Scheme, sort of sticking with the entertaining names after edge maxing. I'm not sure if it's too egregious. Maybe we'll go with something a little more friendly, but for now it's called Pyramid Scheme. For anyone curious, I'm going to post the GitHub right now. And finally, the last sort of interesting thing that I'll point out before I'll kick this back to you guys is, as far as we know, this is the first subnet that was done in Rust. The reason for that is we didn't need a lot of the Python libraries that you typically need for machine learning and that a lot of the other subnets use. And the sort of extremely high efficiency data production was crucial to the performance of the subnet. So again, my more intelligent engineers will be able to tell you about that. And I'll pause here. Hopefully that was a good introduction.
Well, first of all, Zion, usually I tell teams, hey, there's a lot of stigma towards crypto AI that we're trying to overcome, and especially in the more academic realms. And I feel like you're just diving into that. You're like, look, the only way out is through. So hey, look, it takes all types. But I mean, it's kind of ironic because, pyramid scheme obviously has some bad connotations, but actually what you guys are working on at the core of this subnet is deeply mathematical stuff.
That's right.
But I mean, one question I have is, so like, what's the valuable output here? Like, what are we actually understanding or exploring with cellular automata? Like, Keith, you've been on about this for a very long time. Zion's picked it up in some sense, but I know that you've been talking about cellular automata for a while. And like, what sticks out about that technology from Wolfram that's so interesting, and why does it connect Bittensor?
Yeah, so the cellular automata, history goes back to like the 1940s, and there's a guy called John von Neumann who basically invented the thing. He was involved with like the Manhattan Project, a lot of the early stuff around quantum mechanics. He's essentially the father of like modern computer architecture. So the way that modern computers have been built, were based on something that he designed. And one of the things that he got into before he died at a pretty young age was cellular automata. And he created kind of it's a 29 state rule set where you have essentially cells that develop based upon the, parameters of their neighbors. And then, really automata then kind of died off a little bit. And then it was picked up in the 70s by a guy named Conway, John Horton Conway. And this is where Conway's rules, what is it called? Conway's Game of Life. And I'm going to paste the link in here so you guys can mess around with this stuff. Yeah, he invented game theory. The list of stuff that this guy was involved in is unbelievable. There's actually something called it's a self-replicating von Neumann probe, and it's this idea of using a intelligence inside of a probe, like a space exploration probe that would go out to a certain point and then replicate itself and then continue doing that. So there's all kinds of fun applications for this stuff outside of just, playing with evolutionary kind of computation. A lot of people today know of Cellular Automata because of Stephen Wolfram and his appearances on like Lex or any other podcasts he's done around the topic. And he took it to a whole different level with this thing, which is kind of like the Automata Bible. Look how thick this thing is. It's ridiculous. It's written like you've read the whole thing. Okay. Well, it was written in 2002. I think there's like a 2-decade, 20-year version that was re-released recently. I've read about half of it. Anyway, the point is that this never really delivered anything of value, I would say, to computation. And I feel like there's an Easter egg. There's something sort of hidden in all of this work that's been done by these great minds over the past 80, 90 years at this point. And I think that this subnet is a great way to kind of suss it out. The reason why I'm involved in it and on the stage talking here is on Christmas morning of last year, and everything's more fun with a story. So, I mean, you guys maybe didn't sign up for this with with this novelty search. Maybe you didn't know you were signing up. I'm gonna tell a quick story. So, Christmas Day morning, I woke up at like 5 a.m. in the middle of, remembering this dream I was in for like the past, I don't know, a few minutes. And I was set in like the 1950s, and I was in this cabin, and there was a couple other people in this cabin, and there was a guy I didn't know standing next to a typewriter, not looking at it, just hammering at it with one hand in some kind of trance. And I walked over in the dream to the typewriter and looked at it, and it said von Neumann, and then a long number string, and then repeated down this page, 50 times was just von Neumann, and then this long number string. At this point, I'd never even heard of von Neumann. So I wake up in the morning, I'm asked my wife, I'm like, what's a von Neumann? Like, it was in my dream. I don't know what this thing. So I start, and it leads me down this like rabbit hole for Cellular Automata. And long story short, I get this book, listen to every podcast, go deep into it. We launched a shitty subnet that never really got any traction back in, I don't know, December of last year, trying to do something. We didn't have the development horses behind it that, Wombo brings to the table. So the thing kind of fizzled out before it really turned into anything. But I never really let that dream die. And man, and Ben already mentioned this, but it's quite strange that the day or two after that I put this on Twitter, that this team from Yale, releases this paper detailing this work about automata. And now we get to kind of the application of automata to Bittensor and machine learning. Because what this team did from Yale was basically use two different methods. So they trained GPT-2 size model on basically chess using a bunch of games from grandmasters, and then another game that's sort of like a one-sided, a Rubik's Cube, where you can rotate it and change some colors. And the whole idea was to get the model to accurately predict what was going to be showing up on these either chess for the next move or for this pattern identification on this like a Rubik's Cube type logic reasoning game. And if you take a look at that paper, I put the link in the chat. What they were able to do is use a number of sequences extrapolated from something like you see if you go to that rule30.org, that kind of pyramid that develops out of the rule set. Because, basically what a rule set is for Cellular Automata is it looks at the cells around it, decides but based on the rule set, if If 2 cells are filled in, then the thing is going to expand. If 5 cells are filled in, maybe it'll contract. And you can set all these rules up and customize it. So there's many, many different types of rules for like the elementary basic cellular automata. There's 256 different basically sets of rules that are different combinations of these sort of on-off rules based on the cells around this single cell. And what they've done then is take a number of these rules. Some of them end up in just noise. Some of them fizzle out to nothing after a few steps, a few intervals. Some of them actually turn into something quite complex that continues on and is also increasing in complexity as it goes. There's a couple of very well-known rules like Rule 30, which is what this kind of kicked off the idea for this subnet. And that rule is computationally irreducible, meaning that you can't just write a very simple formula to figure out after 5,000 steps what a certain cell is going to be. You have to actually do the work from step 1 to step 5,000 to get there. And so that's, if you'll see, if you take a look at that website by Wolfram, that one of the prizes that they're offering is for basically coming up with a formula to determine what the cell is going to be for Rule 30. There's also Rule 110, which is Turing complete. There's a couple other rules, I think, which are Turing complete. Google that if you don't know what it is. I'm not going to try and explain it, but it essentially means you can use this to compute pretty much anything. And that leads us to the Subnet 39, because this paper lays the groundwork for generating novel, like basically training sets that you can apply to LLMs that will create emergent intelligence in tasks like, for example, predicting the next move in chess or this logic game or really anything. Because if you go back, like there's a paper like 2 years ago around emergent abilities for LLMs. It was pretty popular. I could post a link here at some point. You guys probably know what I'm talking about, actually, if most people here do anyway. Anyway, there's a bunch of things that these LLMs can do once you get to a certain size that they weren't really trained for. Like a common one is 3-digit math. So LLMs are notoriously shitty at math, but once they get to like 10 billion parameters, somehow they can do math at 3 digits. And then if you continue, and that's without training them specifically on math, and nobody really knows why at that exact point these LLMs develop the ability to do mathematics. There is an unlimited number of sort of abilities underlying these LLMs that are only known to be there if you test for them. And then only if you have something like this cellular automata where you can have basically like a subnet, like these guys are going to build the Wombo, that at some point is creating data sets that can be used to fine tune or train these LLMs to increase their capabilities across like a broad spectrum of different, capabilities or these emergent properties, and improve the ability to do pretty much anything using the intelligence at the edge of chaos. And that's the name of this paper, because if you teach these things how to do these various prediction methods, what you end up with is very it almost looks linear if you look at the paper, but when you get the right combination of it's almost too noisy to make sense versus like, well, there's a pattern here, but we can't quite figure it out. And if you train them on those specific types of cellular automata, then you see increased performance.
All right. There's a lot there, Keith. We just went from von Neumann architecture, game theory, all the way to cellular automata and Wolfram Alpha to, so we're staring off into some deep complexity here. So let me just understand this. So by studying or training neural networks on cellular automata, we can learn about different architectures for machine learning models, or is it different data set types that allow us to
imagine
train
the data set? Yeah, it's more like imagine a data set that has, let's say, 60, 70 different snippets of that pyramid that you're looking at on rule30.org. Imagine that pyramid going on for 50,000 steps. And then you take some random snippets out of that pyramid and you teach the LLM, you train it on, a certain number of steps, and then it learns based on that training how to predict the next, color of the next cell without actually doing the math. That's the important part, is that if you look at that paper, it's using the historical sort of calculations to come up with a different way of deciding what's going to happen rather than just applying the formula.
And so like there's this edge or this like inability in modern language models to solve what are seemingly really, really easy problems, right? It's like, okay, count the number of threes in this number, this really large number. And it's unable to do that. But it's, it's capable of writing an essay for me, but it can't count the number of threes or the number of times R shows up, in a sequence of text. And it seems very obvious. And then there's these emergent properties that show up with larger models. And does this mean that like cellular automata, like exploring the space of cellular automata is one way to explore the space of different types of problems? And so we can maybe find architectures that can solve all of these cellular automata or can predict all of them. And therefore, like whatever that architecture is somehow potentially better for like what exactly are we discovering here by studying cellular automata that applies itself to the rest of the world?
It's incremental. Go ahead.
I have sort of a simplistic view on this, which is that the data that we create around cellular automata is almost like a mental steroid. And if you throw that into a data set that you use to train an LLM, and the thesis and sort of the idea behind this is correct, then you'll end up with an LLM that's smarter and that can do more than it was previously able to do because it was exposed to this data.
So we're talking about expanding data sets with random sequences from cellular automata. Just like, okay, here's, Macbeth, and then here's a cellular automata output, and then, now we're training on Stack Overflow, and that's going to actually help a machine learning model?
Yes, and that's what the Intelligence at the Edge of Chaos paper shows, is the sort of surprising result that works and it's effective.
Well, no wonder Wolfram is so smart. So inside of this subnet, are you guys enumerating different types of cellular automata? And how do we find what's the goal here? So we end up with, you're augmenting data sets on this? Or are we just storing every cellular automata possible? Or are we training models? We're looking for different types of architectures. Perhaps that's in here as well, right? Like, so I suppose maybe a transformer block is not the thing that helps us.
We're starting simple. So there's one automata that people care about and has really interesting behavior, and that's Rule 30. To date, only 1 billion rows of this Rule 30 have been generated and sort of publicly shared. The goal of the subnet is to generate 1 trillion rows, so multiple orders of magnitude more. And then once we've generated that data set, then we're going to sort of use it in some kind of training process and see if we can get interesting results out of it. But the first and sort of most basic step of the subnet is to just generate way more rows of this automata than anyone has generated before.
So once we have this data, it's valuable to other machine learning models. You're sort of like just throwing in difficult math problems, or and is there something about cellular automata specifically that has this emergent property? I mean, cellular automata is all about emergent property, right? It's like the study of emergent property from simple rules, and it's sort of the idea that like inside of cellular automata is the entire structure of the universe, and so we're in some sense you're staring into the greatest pool of randomness, like structured randomness, and that's helpful. It's very abstract, very cool, Keith, that you came across this. So if we were to generate a trillion rows here. It sounds like it's just majorly a computational problem. How much data is that?
Right now, it's going to be about 125 gigabytes. So the center column will be 1 trillion bits, zeros and ones. So it'll be about 125 gigabytes in total when we're done.
And how do you tokenize that for a GPT model?
Well, we're not there yet, but I'm thinking we'll do it just as zeros and ones. So the model will actually be fed in like cellular automata data as just as is. And hopefully from that, it'll learn how to generalize the irregular but structured patterns into other difficult problems.
What comes to mind when I think about this is almost like pre-training. Like you like initialize your model on cellular automata before it even sees language. And somehow you've like expanded the weights into some sort of initialization that can converge properly. I don't know. Perhaps that's, is there any research on this? Like, what is the actual thesis of this paper, this archive paper that you posted here?
Well, in the paper, they actually kind of suggested why this happens. They didn't really go too in depth into it, but essentially, there's some sort of hidden pattern if you feed it in a row of cellular automata, and the algorithm, the training process teaches the model how to put more steps into its thinking. So it essentially becomes like, it increases it's called attention in like transformer models. It increases how much attention it puts into the like decision-making process.
So it forces the model to think deeply, kind of like O1. I like that. Your pre-training. Really cool, Keith. So we collect all this data, and so where do we take it from there?
One, we open source it, because that's the whole point of this. We give it to the world. We say, Bittensor produced this, and hopefully that in and of itself ignites research. Two, we catalyze as much of that research ourselves as we can. And, perhaps with Prashant and some of the other AGI-minded people in the community, try to incorporate this into some kind of training process and see what we get at the other end. And three, we keep going.
What's kind of interesting here as well, Zion, like the study of these cellular automata, you have a totally abstract benchmark for intelligence, right? Like one thing I see in this is, and the measure of intelligence is incredibly important, right? So I don't know if you guys have read Colomet's paper on the measure of intelligence and how like benchmarks sort of are what drives the field. I mean, inside of the study of a cellular automata, like the exploration of this deep data set, are you guys thinking that like out on the other side pops like the ultimate measure of intelligence?
That would be very cool.
Maybe
I think if everything goes really well, and we generate this giant data set, and then we move into different rule sets, right? To start, because if you look at these things, they're classified. Wolfram like traditionally classifies automata in one of four categories. It's like it fizzles out, it's just simple and it repeats. It's and they're increasing the complexity here. The third would be like, oh, it's just chaos and noise, and the fourth would be like, it looks like chaos, but it's actually repeating in some kind of pattern that we can't predict, but it doesn't end up in noise. It just continues complexifying into infinity. And and the way that they did it in this paper was they took essentially random snippets from these, primarily the 3 and 4 based complexity rule sets in order to, use the the data that was on the edge of chaos, right? That going back to the name of the paper. And then you feed these into the LLM and you start putting some structure around this with Bittensor, where you can imagine where this subnet would create competitions for, sort of spicing up a model that has these different additions into it, that are creating either emergent properties or charting like very incremental, obvious improvements on things that LLMs can already do. And this, for me, feels like right up Bittensor's alley, is creating a competition between miners to, essentially have a model that's been trained on cellular automata that's then generating improvement on things that everybody uses models for.
Yeah, one thing that comes to mind is obviously what Mutex are doing on, oh gosh, I forget the number, but in NAS chain.
31.
31, where they're studying architectures that can train quicker on CFAR, and inside of that neural architecture search is the goal of finding architectures which are arbitrarily good or like generally valuable. And here Mutex is going to come up on the stage and speak to that.
Hey guys.
Hey.
Maybe.
Can you guys hear me?
Yeah, loud and clear.
Good. Yep.
Right. Nice. Yeah. Sorry to interrupt.
No, I think we were talking about you.
Yeah,
so it's perfect time for you to come to the stage.
Yeah. SN39 is something that I always follow up because we have some common interest in there. But yeah, we at SN31 perform neural architecture search to optimize models for hardware. So we are very hardware-oriented subnet. Unlike a lot of other subnets that might have one objective to optimize, that is accuracy, we would like to have a spectrum of models for a given data set or a task that not only is accurate enough, but also reduces the compute and the memory requirement of that model. So in terms of what we target is we are not even talking about laptops or household computers. We target very small microcontrollers and microchips. So we target your smartwatch or your medical devices that you might want to run an AI on them, but you will have a very limited amount of compute and memory in there. So, and off-the-shelf models that you might find, anything like ResNet, MobileNet, if you just take them out, they won't fit in there. And we perform a multi-objective optimization that optimize three objectives: maximize accuracy, minimize number of floating point operations required for the inference, and also parameters that's used in the RAM. So we would like to discover all this possible combination of layers and convolutional layers and residual connections, number of filters, the dilation. These are all, if you look, possible combinations of how many permutation of these models you can design in compared to off-the-shelf models like ResNets or MobileNets or DenseNets. And we have shown that we can take a model like a MobileNet version 3 and start mutating on it to a degree that it outperforms that one significantly.
And just briefly, for what it's worth, I think Subnet 39 and Subnet 31 have similar goals. And so it's really cool, Mutex, to be in the same space as you, but with like different approaches.
Yes, yeah.
And I think where you're taking the approach of, well, let's explore the space of architectures and give the miners a lot of freedom to propose solutions. We sort of combine them a little bit more, and we say, no, we care specifically about stable diffusion, for example, and get the same result, but faster and more cheaply. And I hope that both of us contribute to some, really useful optimization that make our cheaper and less expensive and more broadly available computational devices more useful. Because
Definitely.
everyone has those, and not everyone has H100s and A100s and B200s. And we need everything to be running AI cheaply and efficiently and in an optimized way.
Yeah.
If we took NAS chain style, Pareto optimization, and applied it to the data from pyramid scheme. Sorry, I just can't every time. But if we did this, because it's actually quite interesting, and said, like, look, we were looking for language models, looking for sequence models that can generally understand, this seemingly random but non-random sequences. What's the outcome there? Like, what do we get potentially out of that optimization? Like the best neural architectures that are just generally good across the board, rather than, so like CFAR, what Mutex is doing is very, and the field is always focused on CFAR because it's explainable, and there's benchmarks around it. But what if we pointed NAS chain at data like that's coming out of 39 here? Do you see what I'm saying? Do you see what I'm asking here? 36, pardon me. Yeah, wow, sorry, 36, getting confused. Like, would that move our neural architecture search towards things that were, overall general in the AI space?
So one thing that is, I might need more explaining on the top SN36 is what objective is being optimized. That was not clear to me. What we are trying to minimize or maximize. And in terms of neural architecture, so for CFAR10, although we are training on we are just evaluating on a single model, but we actually searching for a block of a neural network block that will outperform the existing state-of-the-art block. So one thing you can think, those handcrafted neural networks, like when someone came up with a ResNet block that said, okay, let's just put a residual connection and then this pass the information to the next block to prevent exploding gradients or vanishing gradients or inception blocks. So what we see in the NAS chain, that we're gonna test this actually. So we're gonna test once the block, a design of a block is found as a feature extractor. So I could show some visualization that how much complex blocks that miners have found. Once you find a block, it's all matter of searching how deep you want to go, or how much width of height of that block you want to put in the architecture. And we will test this actually when we switch to a ImageNet, for example. Do we have to start from scratch, and miners are just gonna take their state-of-the-art block and just perform a slow and small mutation on it, and then we, instead of waiting for 2-3 weeks for them to find a new block, would that generalize?
Yeah, just as a brief side note, Mutex, This is the first time I've ever communicated with you. I think there's a lot of interesting things we could collaborate on. So it'd be great to set up some time to chat.
Yeah, definitely.
So we also have another subnet here too to talk about, which is 39, which is also really an optimization subnet. And how far have we come? Like, that one's been out in the wild for a while. And my question is like, what have we optimized down to? And do we have any compelling results from that?
Yes, I'll keep things short and sweet on 39. The objective there is to optimize models for consumer hardware. So taking a model that you normally are running on like an A100 or an H100 and get it running extremely quickly and efficiently with as high accuracy as possible, but on lower end devices. And so our first focus was running stable diffusion on 4090s. And since launching the subnet about 2-3 months ago, we've made that model about 2.5 times faster while being 95% as accurate. Next week, we're going to release sort of a major kind of press release and blog post about what we've accomplished. And not long after that, we're going to expand the optimization to other models and other hardware types. But we've sort of reached that n=1 proof point where the subnet has successfully optimized one model for one piece of hardware. And now we want to scale that out to, a much larger and.
Where does that stack up against other attempts at the same problem?
Well, on one hand, I think it's the most competitive, fastest version of stable diffusion now. But on the other hand, that's happening in a very specific kind of band of this specific version of stable diffusion on this specific hardware type. So that's the caveat.
So long term here, the subnet can be a place where, hey, I have this model I'm running on as a backend for my application as you guys use stable diffusion, and it's costing you X amount of dollars per month because it's so expensive. You have to run A100s. So on this subnet, you could come, drop this into this miner ecosystem, and in a month or so, you've halved the computational cost, doubled the speed, and cost only a little bit in terms of accuracy. So that's real dollars, right? For a company like you, like put it in perspective for us.
That's exactly right, Const. Our biggest expense has always been inference and server cost associated with that inference. Our best hire was a guy who's one of the leading experts in the world at this model optimization, and Prashant knows this guy well. And we basically turned this guy into a subnet. And there's very few people with this skill set. I'll say beyond the sort of business value, I think there's a secondary thing here, which is you are opening the pool of possible compute contributors. And you are going from only the people with data centers can contribute compute to anyone with a MacBook, anyone with a PlayStation, anyone with an iPhone, anyone with a gaming computer can contribute compute. And I think expanding the pool of compute contributors to the average everyday person who maybe knows very little about AI is extremely, extremely important. And that's one of our major goals with the subnet.
In the mechanism for 39, there's sort of limitations you guys have on what they're allowed to do, right? So they have to be able to get 95% accuracy. I'm curious, or like only a 5% reduction in performance. How do you measure that? And like, how do we expand the space that people can evolve these models in to allow them? I mean, because I'm assuming that it has to be a torch model, right? I'm assuming that you're doing quantization. Like, how does it work? What exactly is being employed by the miners? Where are they allowed to go? Are they distilling models here?
I'm going to see if the other Alex is available to answer this. You want to come here, or you want to do it from there? Okay. Other Alex is about to join and answer your question.
Okay, hell yeah. Alex is the engineer that does model compression?
Yes, and our subnet team is myself, and I'm sort of the retarded frontman. And we've got three excellent engineers, and one of them is here now.
Hey. So our miners have been using a lot of different techniques to achieve these optimized models. Mainly what we've been seeing is tools such as SDFast and OneFlow, which is what miners started out with to optimize these models. And then they started to use things like one diff X, which has significantly improved these models. As Ben has said, we've seen like twice as fast or 2.5 times as fast while maintaining like 95% similarity, which is extremely impressive. I can share these models if anyone wants to see them.
Yes, please do. And how do you measure similarity here? Like I'm always a geek for incentive mechanisms, and there's always so many problems that can arise in the design. So I like take us through the journey of how you guys started with this problem and where you got to, like what bugs you had to squash. Because I think like that knowledge, seeping out into the ecosystem, people watch these calls. It's very interesting.
Yeah, we've gone through many different like types of ways to calculate like similarity. We started out with just like simple cosine similarity to compare it between the optimized and the baseline model, and then we eventually figured out like new ways, like using like structural similarity, which has caused like very accurate comparisons. So we know exactly how fast these models are, and we know they're like very similar, if that makes sense.
What is structural? Yeah, what is structural comparison?
Okay, so structural similarity compares like the how well the model looks, like how well it compares to the other model, like how visually similar the image looks, basically.
So are you checking the actual weight, or are you checking the weights of the model, or are you checking the outputs of the model?
I can't explain that specifically. I didn't actually write that system. Our other engineer, Ashley, did. I'm just trying to give you a high level overview. So essentially, I believe it uses weights, like it actually gets the weights of the image and compares that, and then compares how visually similar it looks to the optimized model or to the baseline model.
I imagine it's weights of the model. You're actually referring to pixels of the image by the sounds of it. Okay. Well, it'd be good to get Ashley on if she's here.
Unfortunately, she's not here right now, but I just got word that we're able to demo our secret project. And so if that's of interest to UConst, we can quickly show that off as well.
For sure.
I'm not sure if she's in the audience. Let's see. Sam, are you here? Okay. Sam, you got a request to go on stage, and then we can show you. We can show you off.
Is this another pregnant man?
This is not a pregnant man, I promise.
Not quite a pregnant man.
Hey, Sam.
Howdy. All right, I'm gonna share my screen and show off really quickly one other of Ben's lovely brainchilds. So this is kind of the idea behind an AI subnet analyzer. So kind of born out of Mog's paper, kind of born out of like Ben's brain. But basically the idea is you put in a subnet, you can generate a short or a long report with a couple of closed source models. It gives a score, how it thinks the subnet is doing based on like some framework, download a nice pretty report. And you want more information about any given subnet, you can ask it questions. Yeah, it's pulling in information from Taostats, Discord, Twitter, GitHub, and just basically condenses it all into one place so that you can figure out what you want to do with subnets. That's it.
Let's do one. Let's analyze 39.
Okay, let's do a short report because otherwise it can take like up to like 10-15 minutes, and I don't think we want to wait for that.
And so this is like an agent that goes out, it's scraping Twitter, it's scraping the Twitter, the Discord, the GitHub, it goes through our documentation and tries to analyze it. What's the backend? You say you're using a variety of different models?
Yeah, so you can see they're all like put next to each other so that you can easily compare them and try to figure out like where the discrepancies lie. So Gemini gave us a 7 out of 10. Hold on, I'll pull it up here. Gemini gave us a 7 out of 10. They explain the goals, what the conclusions are, and like some next steps about how Gemini thinks it could improve versus GPT gave us a 6 out of 10. And Claude gave a 9 out of 10. I like Claude model the best. That's a great one. That's really great. And then, yeah, you can play around with the ask feature too. This is a relatively new one, so it's like still a little bit buggy, but this one was really nice. I generated earlier today like a graph of all of the emissions for like Subnet. I think it was Subnet 24. And then I showed next to it all of their tweets and tried to figure out like, oh, was there a spike in emission after like some of these tweets? And like just playing around. The little stats girl in me was having a great time.
And are we currently using this, Keith, to set weights on subnets? Is this your backend?
It's going to become it, I can tell, because this is one of those things that's about to put me out of a job, just like Ref has the, auto validator in development, and you combine this this tool with like a DTAO rebalancer, and we can just hand this whole project off to Rocco's Basilisk and go to the beach.
Hell yeah, I trust that, Keith. Especially if it's trained on Cellular Automata, it's going to be really smart. It'll be better than anything we can do. Really cool.
But
That's a nice project.
Isn't that where we see this going? Is a tool like this eventually being incorporated with AI itself, and many network participants taking their hands off of the wheel and handing it back to AI?
Totally. I mean, if the incentives are there, people will do it. Absolutely. I mean, we have a market. It's plug and play. It's adversarial. It's incentivized. It's mechanistic. You can program it. I mean, the first thing that's going to come out in DTAO is people doing MEV bots. Like we know this. Whether or not that's AI models, whether or not there's a subnet on Bittensor that's trading different subnet tokens, I don't know, but I do think that it will become more and more mechanized over time. Keith, I agree with you, but before it's super sci-fi, I imagine it will be much more manual.
Yeah, just to give my 2 cents, I think the system is not ready to set weights across subnets. I just don't trust it, and I don't think anyone else should either. And we got some great feedback from Xavier about this. But I think the system is ready to be sort of the co-pilot or the partner for an intelligent human in the loop.
I mean, I would be really interested to see where, not only about giving reports here, but potentially where this backend disagreed with the current weighting of subnets. Like that would be quite interesting, right? We can all. You can send a report over to Open Tensor Foundation and be like, look, you guys think you're better than Claude 3.5? Come on.
As long as you don't think I'm snitching, it's just the AI.
Right. It's just Sam in the background.
Yeah.
Totally. Very cool, guys. Very cool. Well, we can end the call here, or we can branch into just like a general conversation if there are questions for us. Christian wants to come up on stage, or questions for the team, for Sam, for Zion, for Keith.
I just want to say one last thing. We've been in the Bittensor community for a little under a year now. We started being totally lost and confused by what this thing was. We're a little less lost and confused now, but it's been an extremely positive and pleasant experience for us. And, the fact that it's lucrative is a nice cherry on top. And Const, Keith, everyone else in this call who's been here for much longer than we have, we're very, very grateful and hope to continue being a part of this. Also, if you're going to be in California in November for that conference, we're going to do a little thing at our house immediately after. And I'm going to drop the event link now. We'd love to see some Bittensor people IRL. Thanks again, guys. Much appreciated.
Thanks, Zion. Wombo and Sami Kasabi, you guys are throwing a party. Ooh, very fun. Adam, you're on stage.
Hey, mate. Cheers. Just a quick one. We have been asked to speak at the staking summit in Bangkok next weekend. So I will be there in person, on stage. Good grief. Trying to figure out what to say for 12 minutes. So if you're finding yourself in Bangkok next weekend, that is where I'll be. It'll also be live streamed, and then there'll be a separate video that'll go up after the fact as well. They heard what we were doing with our crazy underground, bomb-proof validator bunker, and said, "Come talk about it on stage." And I went, "Oh crap, okay."
How is that coming? For all of us that can't make it to Bangkok, Adam?
It's going pretty good. The generator has been relocated. The 120 kilowatt transformer has been installed. It's now sort of like finishing off the niceties of a bunch of things, and so I'm hoping we can start flicking a few more things over to be running in there in the next month or so. The construction on the 670-foot well is slowly plodding along. Turns out that is a really deep bloody hole.
And it's going to be running STOW, as I understand it, Capricious. I'd like to hear you made a really interesting comment in your Telegram group about your implementation of STOW. And I'd like to hear, your philosophical reasoning for implementing it like you did.
Yeah, sure. So we have a staking voting dashboard MacGuffin that will be going live, all things being equal, next week before the presentation. And it tries to follow on the way that we believe that DPoS should work from a philosophical perspective. And that is that all delegators have the right to vote, but all validators have the duty to vote. And so what I mean by that is that, as we've seen in the current voting models, the users that are voting are overwhelmingly voting in self-interest. So for their own subnet, the subnet that they mine on, all those sort of things. Now, if you're voting with your own TAO, and your TAO is your equity in the network, that is entirely within your right to do so. Whether or not it's good or bad is irrelevant from the fact that it is your right to vote that way with your TAO. The problem is that when you have situations where the minority voters on a validator control the entirety of the stake, you're not just voting with your TAO, you're voting with a bunch of other people's TAO that they may not have known how to vote, they may not have known what to vote, and it means that you're stepping outside of voting with your own equity and using someone else's. So whereas the idea of DPoS is that you are delegating your voting power to the validator that you're deeming to be responsible for making that vote. So the way that our system works is that everyone can vote with the power of their own TAO that is delegated, and then we as the validator will vote with the balance that has not been voted for. So the more people that are staked to us that do vote, the more it diminishes our voting authority, and the more that it is decentralizing it over, but it ensures that delegators are only ever voting with their own TAO and not someone else's.
Right. Because the whole premise of STOW being, anti-aristocratic, anti-oligarchic, really turns out to not be the case when only a few people participate in the voting mechanism. So you've actually created a hybrid, and I really like this idea. It's like the people that are not participating in STOW, they've delegated that to you because they trust your opinion about how the subnets are working. And for somebody to go and just use a small amount of TAO to sort of overwrite their delegation, feels almost fraudulent. I really think that it's a beautiful approach, right? So in practice, like looking at, say, I know Datura and Muv and Owl are all currently applying the strategy, including yourselves, what percentage of your stake is voting? So like how disproportionate is it? Is it like, like just the people in Pennsylvania get to determine the election? Is it that bad?
So I think on MEV, I'd have to check with their steps. They probably have the highest percentage that's voting with MEV because they kind of launched with that process. Versus OWL has only just opened it up in the last week, so theirs is very small. If memory serves, is probably about a quarter to a third of Datura that votes. So it's quite disproportionate there. Versus with us, well, the dashboard hasn't launched yet, so it's zero. But we hope to see that increase over time. But as it does, it's diminishing our voting power, but not changing how much voting power individual users have. They will always have the same amount. And as much as I'd like to take credit for the idea, it does more stem from the voting models used in things like the Cosmos ecosystem and that. Although one thing that we're doing a little bit different is that, say you go through and you go, look, I think that this subnet deserves 10%, this one deserves 10%, this one deserves 10%, but as for the other 70%, I don't freaking know. And you want to leave that portion unvoted. Likewise, it only uses 30% of your voting power as a delegator to vote for those ones that you like, and it leaves the other 70% that you have not voted in the defer to the validator's choice. So you also don't have to go through and figure out where to put all 100%, because as the number of subnets grows, that becomes a bigger and a bigger task. You might just as a holder go, look, I really love subnet 99, so I want to put some there. I don't think it needs 100%, but I'm going to put this chunk. As for the rest, I don't want to think about it. Someone else can pick. So that's sort of a part of what we're also trying to build in.
This is great. What's really brilliant, I think, about how this is happening organically in the community is that we didn't have to implement this on chain. Like, it literally evolved from individuals building off-chain solutions to make bottom-up democracy on the chain. We wanted to actually implement STAO back in the summer. We didn't do it because we're going to jump to DTAO. And it's so great because we would have had to do 2 massive upgrades into the network, whereas now we can just let this one happen organically and focus on the major launch of Dynamic DAO. So I actually really appreciate it, and the idea came from Muv. So shout out to Muv for putting this out there first, but also really curious, to see, how it's done in the Cosmos ecosystem. Like, what exactly is the structure there, Capricious? Is it just like you described?
Yeah, so the way that it basically works in Cosmos, and it's bajillion Cosmos chains, is that there'll be a main staking and governance dashboard, and people can also host essentially mirrors thereof. And whoever they're delegating to is completely separate from the voting process. So they go off and they vote yes or no on a given proposal, or they just don't vote at all. And then the validators can also vote. The validators' voting power is however much is staked to them minus whatever portion of their user base voted. So if they had 1 million tokens delegated to them and 300,000 tokens of voting power went off and voted, be it yes or no, the validators' vote is basically then 700,000. And that sort of maintains that situation where the validators are expected to have a very high governance participation rate, where they are expected to go in and review the proposals and vote on everything and be involved in that process. But then delegators, they have the right to vote should they choose, but not the obligation. That obligation is on the validators, who are the ones who are ultimately responsible for running the network.
Very cool. It's a liquid plus representational democracy hybrid that I think we should all implement if we get the code open source from you, Capricious. Thanks for pushing this. It's fantastic. Keith,
Yeah, so
I'd like to. Oh, go on.
I was just going to say, so basically, once we've got this working, what we're just trying to figure out is what's going to be the sort of easiest way to do things. Is either sort of everyone implementing their own version of this, or do we try to basically make it so that people can vote and then just select from whatever validators have gone, yep, put me in the system, and then we just sort of go, stake to whichever of these and vote accordingly, sort of having them all on one dashboard. That's what we're just got to sort of get some feedback from people. What would they rather, run their own or try to have something a little bit more unified? It's whatever floats everybody's boat, I guess.
Keith, I'm curious your thoughts. Like, you've seen it from the beginning, right? You're one of the earlier setting weights. You had your everyone gets a weight if they come on the podcast strategy for a while. That's adapted. That's changed. It is a really difficult problem to solve as an individual. It tells you a lot about what it's like to be a politician in some sense. But where have you gone mentally or strategically about how you set weights on Bittensor?
I just try to keep up with the development as best I can. I'm a one-man shop here, so I'm doing all the subnets that I run myself. I don't child hotkey anywhere except in like case of emergency. So I think I'm doing it on 12, but that's the only subnet at the moment. It is tremendously difficult, even if you have a team of people, to agree on these type of things, and any type of sort of democratic solution that's being battle tested by other validators is the direction I'll move towards at this point. Simply because the knowledge of the group is going to always outkick, whatever a single person can do. And the evolution of the validators from, like 2 years ago, when I started validating, there's really only two types. There's legit, and then there's the weight copiers, and that's pretty much it. And now we've got all kinds of versions of different value propositions popping up across, and we're seeing the number of validators expand now too, even before DTAO, which a lot of us kind of thought it might go the other way. You're seeing validators build bunkers. You're seeing validators go almost completely bare metal and running their own hardware if they don't have a bunker, like Rizzo does. You've got validators that are running the most important tools in the ecosystem, like Mog does. Or, you've got different plays like Foundry or myself, or maybe even Polychain, who are using their positions and their resources and the amount of tau that they've gained to fund subnet expansion. You've got the PR validator still chugging away. Roundtable, is doing his unique stuff. So for me, when I see all these different players in the ecosystem branching off into different directions, and then you see something like what Capricious has done, start to get traction amongst the group. I think in the same way that, you've seen subnets pick up different capabilities from other subnets, like with the developments on 19 from Namarray being incorporated into half a dozen other subnets now with the template that he built. It's awesome to just see the same thing happening, like you said, without anything happening with the code base. You're seeing all different strategies being tested out by network participants to gain more nominators and more tau behind sort of their mission.
Cellular Automata.
Yeah, and that's what our validator is. I'll always take the most democratic approach. So if I can use this tool to give it back to my stakers, then I'll definitely do that. And then what we do with our tau that's left over is we fund awesome subnet ideas. Like we'd funded subnet 11 Dippy, which is kind of, if you're not familiar, anybody, it's Bittensor's version essentially of character.ai. The second most visited, AI website. And then, the second one here is the Cellular Automata with the guys from Wombo. And we'll continue to, as soon as those tau come back to us after these subnets are successful over a period of time, we'll then register another subnet and do it again and just keep pumping these new subnets into the ecosystem. And I know others are doing this as well. Easily more than half of the subnets, even if we don't talk about it all the time, are funded by larger players in the ecosystem that are eager to introduce new teams, new developers, new ideas into the competition for subnets. So it's awesome to see that happening as well.
One of the things I often ponder is how, I mean, I've worked in different types of companies and organizations before. And within inside a single organization, say like, you know, at Wombo, like there's a single hierarchy and there's a single structure and there's a single idea that usually comes down from the leader of the organization. And you can't really avoid having some kind of top-down approach to your single organization, usually the single structure, the single equity, you know, vertical, a single HR department. Whereas, you know, in what we've built here, like it's amazing to see the different types of individuals that find niches, right? In a much more, it's like a much more contoured landscape, right? There's like speciation that occurs. You know, we had mutex, we have mutex up on the stage, right? It's all about neural architecture search. Like in genetic algorithms, you know, one of the most important things is that you have speciation, like you have pooling. You don't just force everybody to compete into exactly the same hierarchy and cut away everything immediately, but allow there to be, you know, different verticals of improvement. And so I think that like the more that we can stimulate that, it's one of the best things about this network is, yeah, we have a validator in Kazakhstan building a military nuclear bunker. And then you got
maybe not nuke proof, but close.
Come on, just do it for the memes, capricious. You know, and all across, and then you got Keith, you know, the single man team. I think that's so rare and so important for our community and our culture, and also for like, we're strong in our diversity, you know, but not in a totally cliche way. Great, guys. Well, why don't we end on that inspiring note? Zion, is pleasure. Keith, pleasure. Mutex, thanks for coming up on the stage. Capricious.
Yep. Thank you for having me. Thank you.
Samuel, Distributed, thanks for being here. Everyone else in the community there, in the audience. Yo guys, go stake to OTF. We need to beat Mog. There's my plug. I come cap in hand. I'm just kidding. Yeah, guys, have a good night.
Bye.
Bye.
Bye.